here we are again. Thanks for coming in. Daniel Esteves, Barry Duggan, who we've seen before. George Mormon is also here. And I think Derek Kozel is also somewhere around here. Thanks for being here. I'll just hand over the microphone to Barry as a host. You're the new host to this session now. Thank you.
Okay. Just wanted to make sure you can hear me now. Can you? Yes? Josh?
Yes, perfect.
Okay, good. Okay, the plan is that we will have a brief presentation from each of us, and then we will open to questions. So let's see, Derek on?
I am, but let's lead with Josh. His presentation's live.
Okay, Josh, take it away.
All right. So thank you, Barry. Thank you, Marcus. And so I'm currently the co-maintainer of GNU Radio Codebase, focusing mostly on the master branch, and want to step through some of the recent big features that have gotten released and some of the things that are coming up soon. So next slide, please. All right, so the first one that's probably of a lot of interest to this community and has been released in the most recent 3.9 release is SOAPy SDR, GR SOAPy. So this is a wrapping of an out-of-tree module that was written originally by the LibreSpace Foundation, and it wraps SOAPy SDR, which is, it's a generalized interface to all kinds of SDR hardware. It's modularized, and it makes it easy for, when a new radio comes out, to modularize that interface and have very common parameters for setting up the common things. So this SOAPy SDR itself is maintained within the Pothos ecosystem. So bringing it into GNU Radio, it allows out-of-the-box support for all types of radios that you'd have to fish around and find the right out-of-tree modules, whether you're using Osmo SDR or some other out-of-tree module. So right now with this in 3.9, you can just drag in an RTL SDR source or a Lime SDR sync. So it's just one less thing to worry about in getting your GNU Radio installation going. Next slide, please. The next big module that's going in our next release of GNU Radio, is currently on the master branch, is GRIIO. And so this adds native support for Pluto SDR and other IIO devices. So IIO being a general industry standard for communicating with all kinds of devices, mainly for analog devices. So Analog Devices has maintained this GRIIO for several years. And so we've got it updated and upstreamed, and you can now just drop down a Pluto SDR source, and we plan on expanding this to other analog devices types of radios. Next slide, please. And then the other big module that's come in recently is GRPDU. So if you're not familiar with a PDU, it is a data format in GNU Radio that packetizes data with some metadata. So you can pass around packets of information. And this is a set of tools, set of blocks that was developed originally at Sandia Labs. And we've upstreamed that with the help of Jacob Gilbert there at Sandia, and gotten it into GNU Radio Codebase. So now you can do a lot more slick things with these types of packetized interfaces. So next slide, please. So the releases that just went out, thanks to Jeff Long, who is our co-maintainer, and he's been very active with getting features and bug fixes back into the stable branches. And so we have a 3.9.2 release, which actually brings the whole new module into the stable code branch, because GR SOAPy is very isolated. It's not going to impact the rest of the code base. It was safe to bring that into the stable branches. And because it just wraps SOAPy STR, there's not a lot of chance for that API to change. So that's there. So that's usable immediately, and it's actually on our PPA and under the Debian packaging that Maitland does. And then 3.8.3.1, it brings in a subset of the features that were suitable for bringing back into 3.8 release. So if you haven't quite migrated up to 3.9, with all the PyBind upgrades and all that, and you're on 3.8, there's still lots of bug fixes still going into 3.8, and we expect 3.8 to be well maintained for quite a while into the future. All right, next slide, please. So what's coming up? So you might have noticed that these stable releases have been happening fairly often. So we made a decision a while back to go to fixed release cycles. So about every 3 months or so, we're doing releases off of the maintenance branches to get those bug fixes out there, and then about every 6 months or so, we're going to do a release off the master branch, which our next one will be 3.10. So coming up in 3.10, so GR SOAPy already went out in 3.9, so that'll be on 3.10 as well. We'll also have the GR PDU and GR IIO. And then there's a big feature that we expect to go into 3.10, which is custom buffer support. So this allows some improved data movement in and out of hardware accelerators. So if say you've written some blocks to run, or someone has some blocks to run on GPUs, this will take away some of that bottleneck getting the data on and off GPUs or FPGAs or any other type of hardware accelerator. It kind of breaks apart the data transfer from the GNU Radio buffer scheme into the custom buffers. You can just design your own buffers to match your hardware. We also move up to C++ 17, so there's some language things that you can use now in your out-of-tree modules and in the main code base, and then also other bug fixes, remove some deprecated blocks, and some big improvements thanks to Ryan Volts with the CMake and getting it more suitable for Windows builds. So I believe that's all I had. I think that's the last slide. So those are the GNU Radio updates.
Okay. Thank you, Josh. Lots of exciting stuff there, and I've already been testing a little bit of the SOAPy and IIO functions in the master branch, and only found a few little glitches, but that's expected.
Yeah, now's the time to fix them, right?
Right. Derek, don't see your picture up there, but can you tell us about SETI and ATA? Is Derek with us?
MW0LNA, and for this year, I'm president of the GNU Radio project. But the more relevant hat that I have at the moment is that I work to be the bridge between the GNU Radio project and the SETI Institute, the Search for Extraterrestrial Intelligence. We partnered up the two organizations in the fall of last year. And if you want to find out a lot more about that process, we have a great talk from the GNU Radio conference and a blog post that kind of digs into the details of that. But this has been something that's kind of been a while coming, and it brings a bunch of interesting opportunities to GNU Radio and by extension to anyone participating. So anyone in the audience who wants to dig into anything that we're talking about, the door is open. The SETI Institute is primarily a research and education group. They have a very scientific mission, and they deal with a lot of radio astronomy type problems, very high bandwidths, dealing with radio frequency interference with their telescopes, how to process large amounts of data, and fundamentally also how to communicate their goals and these sciences to students, to the public. And so they looked at GNU Radio and said, this seems like a really good partnership. Let's set up this system where we're going to work together, and we're going to create some educational outreach slides and resources and examples. Let's try and get people using radios more, understanding what radio technology is. And so I'm very pleased to say that we're now into our second summer working with them. And the main resource that we're using is the Allen Telescope Array. This is a set of 42 6-meter wide dishes in Northern California. And they have receivers that are able to operate from kind of the UHF range. They have two different feeds which have slightly different low-end frequency responses, kind of 300 megahertz or so, all the way up to 10 gigahertz. And so these are receive only, unfortunately for us, but very sensitive. And so we've been able to partner up with several groups of students over the last year and demonstrate receiving, for instance, amateur radio moon bounce. So we had the Stanford University Amateur Radio Society calling out some greetings to different student groups. The recordings from that, I think, are already being made public, and we'll definitely be repeating that with new groups of students this summer and posting that up, both the raw IQ files and the demodulated audio. All of this is being done with GNU Radio, and so the hope is that through this, more tutorials will start coming out showing introduction to GNU Radio, introduction to signal processing, and making use of all of the experience that we're getting from the SETI Institute. And they have a partnership, a center within the University of California at Berkeley. And so we have actual teachers, actual instructors who know how to communicate this in a much better fashion than perhaps we've been able to do in the past. So that's kind of the educational outreach. There's Daniel Estevez, I think, is going to be possibly touching on some of the satellite work that's been done there. If not, there's a video up as well from a recent conference, the European Conference on Amateur Radio Astronomy, EU-CARA. Those are up on YouTube, and there's some examples of using GNU Radio with these large radio telescopes. So the hope that we have is these become reusable parts. You know, if you're interested in extending your amateur radio operating into kind of radio astronomy or moon bounce, you'll be able to start reusing some of these resources. Some of them are already up on the wiki. So if you search Allen Telescope Array on the GNU Radio wiki, you'll be able to find some of those. And certainly at the GNU Radio conference this fall, there will be some talks and workshops talking about these sorts of things. So we're still early days in this partnership. We don't know entirely what's going to come next, but we're looking forward to being able to have access to this really great hardware, and hopefully the improvements to GNU Radio and the lessons learned transfer out to everyone who's using it.
Great. So speaking of satellites, Daniel Estevez is going to talk to us a little bit about GR satellites. And Daniel, they have the slides you sent me, so you can give them a cue when you're ready to go to each of the slides. Go ahead.
Hi, I'm Daniel, GR Satellites main developer. Marcus, can we have my slides on the screen?
Yes. Okay.
Thank you. So GR Satellites is a GNU Radio out-of-tree module. And for those of you who are not so familiar with GNU Radio, that basically means it's an application built using the GNU Radio framework. And GR Satellites is used to decode amateur radio satellites. That's basically any kind of satellite that transmits on the amateur radio bands, mainly on the 2-meter and 70-centimeter bands. These satellites come from amateur associations, research and student projects from universities, and also some private companies. GR satellites can also be used to decode other satellites which use similar protocols, and even some deep space probes. And we've been using that with both AMSAT-DL at the Bochum Observatory, which is a 20-meter dish, and with the 6-meter dishes at ATA, which Dirk talked about, to decode satellites all the way to Mars. You can download the source code of GR satellites in GitHub. Of course, this is all open source, it's GPL licensed. And it's also packaged for several Linux distributions, and it's also available as a Conda package. So that means it's multi-platform. You can install it on Windows, Mac OS, and Linux. Next slide, please. These days, you will use GR satellites through the command line. So GR satellites comes with a command line tool, which is called GR satellites, and you would run it like this. You would type GR satellites, then the name of the satellite, for example, Funky1, which is a satellite from AMSAT, and then you have many different options to select where to get the input from, different types of decoding you can have, or where to put the input. So in this example, we use -- WAV file to take the input from a WAV file. And in this case, it's a very short recording of a packet transmitted by Funky1. All these examples come together with GR satellites. So you have like a whole library of short recording clips from satellites. And once you press enter, you would start getting the demodulated data on the terminal. So it looks like this, a packet from the BPSK downlink, and then you start seeing several telemetry variables, like the voltage from the solar panels. Here we see 0 because in here the satellite was at night, like behind the Earth. But nevertheless, we see the battery voltage, that's 8.1 volts. Next slide, please. You can also use GR satellites in GNU Radio Companion, which is the graphical application that GNU Radio uses to build any kind of decoder or transmitter. So in here, the main block is the satellite decoder block, which bundles together all the functionality of GR satellites. It's as simple as selecting any satellite you want. Here again, Funky1, the sample rate you want to work with. And in the input, you put those signal samples, IQ samples, RF samples, and in the output, you'd get messages, PDUs, with the demodulated frames. You can send those into any blocks to do whatever you want. For example, here we have the Telemetry Parser, which does this decoding of telemetry variables and writes the output either to the terminal or to a file, as in the example. And we also have this hexdump sync, which just prints out the packets in hexadecimal. Using GR satellites in GNU Radio Companion gives you a lot of flexibility about what you can achieve. For example, you could have an SDR source, like an RTL SDR or a USERP, and have several different satellite decoders for different satellites transmitting in different frequencies, and classify everything into different files or whatever you want to do. Next slide, please. Behind the scenes, everything is controlled by some YAML files, which specify the configuration for the satellites. YAML is some kind of file format like JSON, which is intended to be human readable and human editable. And it's also used in GNU Radio to encode the GRC blocks. So I thought it would also be a good idea to configure satellites in GR satellites like so. So the configuration is very, very simple. And in fact, many users are already writing their own configurations for new satellites and submitting them upstream. As you can see here, we have basic metadata like the name of the satellite, its RAD ID, and then down in the bottom, we have the single transmitter signal we could have a satellite transmitting different signals or protocol, but in here it's just one. And we have the frequency, we have the kind of modulation, the baud rate, and the framing. GR satellite is able to understand all of that and behind the scenes put together a flow graph with the different decoder blocks to make sense of the data. So this is all I wanted to tell you about GR satellites. Back to you, Barry.
Okay, thank you, Danny. Okay, Marcus, if you'd put up my newbie guide to GNU Radio on there.
Sorry, say again.
Do you have the link for a newbie guide to GNU Radio?
Which link?
Do you
send
have
it to
my
me?
outline? It's in the outline. Just go to the wiki and type newbie guide. Would probably find it. the what I'm seeing is so fuzzy I can't even read it. But yeah, on either stream, seeing it.
Newbie guide.
Yeah, newbie guide to GNU Radio. Yeah.
Okay.
Oh, there's going to be a link there.
What's the name of the... Ah, there it is. Okay. Blank was missing. Okay.
Okay. Okay, I'm going to put, like I say, mine's so fuzzy I can't even read it, but let me get my copy of it here. Okay, this is a brief overview for absolute beginners. 2.5 years ago was the first I had ever heard of GNU Radio, and it was overwhelming. So I decided, first of all, I'd help with some documentation, but then I've also been writing various tutorials, and this guide is actually a fairly recent one for the rank beginners. So it's a where do I start? So one of the things is the main page, which can be seen here and also any place in the wiki. Over on the left, the top item says main page. That's an excellent summary of all the various aspects of GNU Radio. And we'll skip over tutorials for a moment because we'll come back to that. The block docs is a listing, alphabetical listing of every block in GNU Radio, over 400 of them, 435 or something like that. So you can look them up. Oh, yeah, you're showing that, good. They're alphabetical. And then when you click on one, it will show you the details for that block, the parameters, hopefully an example flow graph. I've been working on a lot of those, and various other explanations. And yeah, audio source is a good one. And it shows the parameters. And if you scroll down a little bit, it shows some explanation. And then there should be an example flow graph at the bottom. There you go. So we're trying to do that with every block. And I certainly encourage any help we can get in that area. Now also,
If you're within,
say again?
I was just going to say, if you're within GNU Radio Companion, you can open up this block documentation from within the block properties of any block.
Oh yeah, that's something fairly recent feature. If you click on a block when you're in GNU Radio Companion and then go to the documentation tab, there's actually a link to take you to that block doc. So it's a quick and easy way to get more information there. The GNU Radio repository itself has lots of examples. And for example, the free DV blocks that are shown on this newbie guide. But within each of the sections, digital, analog, whatever, there is an example folder that will give you the applicable examples for that type of operation. And then a valuable source of information is to subscribe to the Discuss GNU Radio Digest. And you can do that by clicking on the mailing list link there in this newbie guide. And it also shows up some other places too. But once you subscribe to that, you get a usually daily email with a summary of what's new. And once you are subscribed to it, then you're allowed to submit questions. If you're not subscribed, you can send your questions in and they get dropped on the floor. So you definitely need to subscribe before that part will work. And then finally, the Matrix chat rooms. We use Matrix for a number of our chat rooms, one of which is ham radio. And there's a link there for subscribing to that. Now, Marcus, if you'll go back to the tutorials page, there was a link on the newbie guide that said GNU Radio Academy, and that will take you to the tutorials page. Can you put that up?
Yeah, okay.
Yeah, you got it? Okay. There again, I'm still seeing this very fuzzy, but I'll look at my own copy. Okay, this set of tutorials will take you from beginner level, introducing GNU Radio, SDR, DSP, and then the GNU Radio Companion and flow graphs. So all the basics there to get you started. And then if you're on a version 3.7 and need to upgrade, or you're on even 8 and want to go to 9, this porting existing flow graphs will help you get there. And then understanding sample rate, which is a confusing issue for lots of us who have a electrical background instead of a DSP background, and one on IQ and complex signals. And then we have a series of simulations here, and these are all simulations versus any hardware required. So we do frequency shift keying, AM transmitter and receiver, which are back to the old days of ham radio, single sideband, narrowband FM, and then a little more complex, the QPSK, and then the BPSK, and OFDM. So those are all explained, like I say, without needing any hardware at all. And then the next topic is using GNU Radio with hardware, and that covers a lot of the different hardware involved. And then Python and writing your own block using an embedded Python block, which is an easy way to get started rather than making an out-of-tree block. And polymorphic types, which Josh mentioned earlier. Stream tags, which I think were covered in the European Radio Days, one of their talks. Messaging, understanding ZMQ blocks, which I presented a couple hours ago, and out-of-tree modules and YAML files and writing blocks in C++. So this is a pretty thorough course in GNU Radio that I highly recommend that you work through. Okay, we have covered the material that I planned. And do we have any questions? And let's see, what's the best place to look for the questions here? Oh, live stream.
Yeah, well, I can't follow the live stream right now because I'm presenting. Otherwise, you wouldn't see.
Right. Okay. I just switched over to the live stream chat box, and
So it looks like there's a question
interesting
for
topic here.
Derek.
Yeah,
it looks
go
like there's a
ahead.
question for Derek about the easy to install project.
In terms of making GNU Radio simpler to use. So one of the many things that people certainly find first when you're trying to get GNU Radio set up is that if you're on Linux, if you're on a recent version of Ubuntu, installing is as simple as installing, through the software repository built into the operating system. And that gets you a pretty recent version of GNU Radio. If you're really in any other situation, it has historically been mixed levels of difficulty to get a recent version of GNU Radio installed. On Mac, using either Mac ports or Homebrew has been really your only option. And on Windows, there's long been a history of best effort binary installers. Part of the difficulty is that there are dozens of ways to install GNU Radio on any of these operating systems. But I'm very happy to say that really over the last year and a half, 2 years, there's been a lot of work on Mac OS and on Windows to make GNU Radio run more smoothly, more stably, and to make it simpler to set up the initial GNU Radio installation in such a way that you're still able to make use of these third-party out-of-tree modules, plugins such as GR satellites. So there are still lots of ways to install GNU Radio. We have not standardized on any one. But if you are looking to get started, my recommendation would be to take a look at Radio Conda. This is available on Mac, Windows, Linux. It's a one-click installer. And there are instructions for it on our wiki. I suppose we don't have a great way of dropping it into chat, but if you search for Radio Conda on the GNU Radio wiki or just GNU Radio, Radio Conda, you'll find the installers. And that is getting to a point where it's having a lot of success.
The next question was, any chance of getting these amazing documentations in the GNU Radio source code to appear when requesting documentation? As far as source code, every BlockDoc page has a place at the bottom with links to the source code. Not all of them are filled in, but that is the overall plan. As just off the top of my head, there's one for the C and one for the H, and sometimes if it's in Python or something, that link will be in there too. So there are links, hopefully, and if anyone wants to help fill those in, that would be wonderful. Okay, the next
Barry, if I may
comment, or yeah, go ahead.
So there's a few ways of kind of dealing with documentation. We used to be pushing for it to be included in that documentation tab in GNU Radio Companion. But the problem was that the only way of updating that documentation is by changing the source code. And this is great if you're a GNU Radio developer, if you're an experienced software coder, but it's not low effort. And there were many, many people who weren't able to make edits. And so the documentation remained out of date and minimal for most blocks. By moving the documentation onto a wiki, you don't even have to create an account. You can open up a web browser to any of these documentation pages and say, this isn't quite right, or I found this bit confusing. I think I could add a sentence or two which would make this clearer. And you can immediately edit the page And if you're not logged in, it'll get queued up for Barry or someone else viewing the wiki to review it and merge it in. Or if you're signed in with an account, that edit goes immediately live. And so we're finding that there are many, many more contributions to documentation. And this is definitely a great thing if you're finding areas of GNU Radio that aren't well documented. Please do contribute immediately. We are looking more in the medium to long term at how to build that more directly into GNU Radio companion so it's immediately visible. But right now it's you click a link and it opens the web browser.
Okay, thank you. Yes, I am one of the moderators of any additions made by people who do not have an account, but it's easy to get an account. It's in one of those links for the wiki. And so if you'd like to contribute and have your name attached to it, then please do sign in, request an account, and then go for it. You don't have to ask first. It's like the chat rooms, just ask or just say. Oh, there's one other comment question here. Not everyone has constant internet access when playing with GNU Radio, so a local copy would be nice. Anyone have any comments on that? I know that a lot of times I'll build my flow graphs and stuff without necessarily being online, but then sometimes you need it and sometimes you don't. Am I correct, Josh or Derek, that you don't have to be online when you're building a flow graph?
You don't have to be online when you're building a flow graph, but I think Derek touched on this. There's a trade-off between having the documentation in the source code and in the source tree, as opposed to on an online wiki. The former it's more convenient, if you're offline and for having everything in one place. But having it hosted in a wiki is certainly much more convenient for people that are not as familiar with the source tree and making GitHub pushes and all of that. So it leads to probably more thorough documentation. So there is that trade-off. Also, as Derek mentioned, in the future, we're looking at different ways of integrating things more closely into the installed GNU Radio, having the documentation more tightly coupled. But there's a lot of ways to do that, and we haven't really settled on one going forward.
Right.
There are tools available right now that you can use to download a copy of the wiki, or even to download a copy of all of the current block documentation and make it appear in GNU Radio Companion. It doesn't handle equations well, it doesn't handle web links well, and it doesn't handle images at all, which is why we're not running that by default right now. But message heard, it's a work in progress. No promises when, but we realize it's needed.
Yes, definitely a good topic to bring up.
Yeah. Now, I know that everyone doesn't clone a copy of GNU Radio, but if you do, and it doesn't take but a few minutes, then you have your own tree to look into the source code. And a lot of times I do that rather than doing it online.
Mm-hmm.
Let's see, did we have any other questions? Frank Werner, I'm on a Mac M1. I understand there are a lot of challenges in that right now, but we do have some people addressing the Mac installs, and there are links in the wiki to get to that. And then get on chat and ask questions if you run into specific problems.
specifically about the Mac M1, myself and particularly Daniel Estevez actually just worked through this last weekend, and there is a write-up on the steps to get GNU Radio running. It's not ideal, it's not perfect, and we're currently blocked on Google figuring out how to deal with the Mac M1s, but hopefully by the end of the year it should be back to being well supported.
Good.
Yeah, so actually we had this installation on the M1 Macs of some of the students at the ATA. And what we did is to use Docker Desktop on Mac. There is a project by Igor Freire on GitHub where he has a Docker container that works for M1. And with that, we got a working GNU Radio installation. The only difficulty is accessing your SDR hardware from inside the Docker container. So we are currently working on ways to sort that.
Okay. Since we have a few minutes left, I'd like to point out one more web page. Marcus, if you could find talk:/ham radio.
Say again, talk.
Yeah, let's see, get the right link here. Yeah, talk:/ham radio.
Like this? Talk ham radio. No.
Talk:/ham radio.
I mean this page here?
Yeah, okay.
Okay.
Yeah. That is where we post all of the information about our mostly monthly group meetings. And you'll see we have postings for today. And then I wanted to point out the one next month. Tom McDermott is going to do one on using GNU Radio for amateur radio measurements, which I'm looking forward to quite a bit. Noise figure, dynamic range, that sort of thing. And then in August, we actually don't have a schedule at the moment. And then, of course, in September, we have the GRCon 21. And there will be a group breakout session on Friday afternoon for that. So if someone would like to volunteer to do a session in August, that would be great. I've asked 2 or 3 people and haven't gotten any commitments yet. And then future plans after that are certainly welcome. There's a place on that same page. I've listed a few suggested topics. There's a place to ask questions on chat, or you can email me. And then, so not only suggest topics, but volunteer to present those topics would be great. Okay, well, we're close to our time. Does anyone have anything else they'd like to cover?
I'd like to make a general shout out. GNU Radio is entirely developed by the community. There are no employees of GNU Radio. There's no GNU Radio company. And so we're always looking for people to help out. All the leadership is volunteer-based. I wanted to point out, Barry has been doing an excellent job with the documentation, but GNU Radio is a large project, and we always need fresh eyes and different perspectives. So if you're interested in that, we could definitely use volunteers for improving the documentation. What else did I particularly want to bring up? We're looking at starting to translate the GNU Radio Companion interface. So there may be opportunities to help translate starting just with the basic user interface and then getting more complicated from there, coming up in the next couple months. If you have anything you'd like to talk about that you've been using GNU Radio for, the GNU Radio conference is coming up in a couple of months, and there's opportunities to participate in that remotely and online, either as a participant or as a speaker. I have a particular one that I wanted to bring up, and I've lost it at the moment. But joining the chat's a great place to get involved. We have, I wanted to mention, if you have, we're trying to improve the support for GNU Radio for drawing data in and controlling amateur radio rigs using rig control and directly supporting, for instance, the Flex SDRs, the Flex Radio SDRs. And so there's some initial blocks that are starting to become available there. That may actually be a topic for August if no other speaker comes up. And so just generally, if you're interested in getting involved with GNU Radio, you don't have to have an extensive knowledge base to get started. Please do join us in chat, join us in the mailing list, and we can help pair you up with some area of the project that's a good match. The one I had forgotten, we're trying to improve the user interface as well, just the usability and the workflows for it. There hasn't been a lot of attention paid to that in the past. Best efforts, but it hasn't been a first-tier feature. We're really thankful to have volunteers coming on board and helping to contribute there. And so there is a UX studies group. You can find the information on the wiki, or I'll make sure we post a tweet about that soon. And that's just anyone who has used or hasn't used GNU Radio can join in on that and help us evaluate kind of new changes to how bits and pieces of GNU Radio work, hopefully making it easier to understand and use in the future. And that's that would be a great thing to have more volunteers for. The more the merrier.
Yeah. I'm glad you mentioned that UX study group. Actually, there is a study being conducted by Bernard, where he is looking for participants in every level of experience, from rank beginners to seasoned veterans, to find out how they use GNU Radio Companion, what they like, what they don't like, what works well for them, and that sort of thing. So if you would like to be part of that study, there is a link. Let's see, what's the quickest way to find that? Quickest way is to get on Matrix and look for that that group. I don't have a link at hand here. Let's see. The room is the grc-dev:/newradio.org, and the room title is GRC Development. So, and you can get on there and volunteer for this study and help contribute to the future of GRC.
And that's being led
Marcus,
by
I think
Bernard Tyer's EI8 FDB.
Right. Okay, Marcus, I think we've about consumed our time and haven't seen any more questions.
Okay, there.
Oh, Frank Warner said.
Yeah, Frank Warner.
Yeah, I have a American pronunciation of names. Sorry. Maybe you want to post on Twitter. As far as the study group, I assume he's asking. That would be good if it hasn't already been put out there. Maybe Derek can say something again on Twitter about that.
I think there was a post 2 months ago, but certainly this new study hasn't gone out on Twitter. So we'll make sure that happens this weekend.
Good. Okay, Marcus, thank you. And thank you to Derek and Daniel and Josh for participating with me.
All right, thank you, Barry.
Thank you, Barry. Thank you for presenting those interesting things about the documentation, how to find your way through it. And you know, here in Germany, we're actually just right now, or in these months, in the process of redefining license exam questions, and we're thinking quite a lot about how to teach about software-defined radio. That's actually a very difficult topic. I mean, we've all passed our exams. I've passed my exam. When was that? 80, 89, at the age of 14. So quite a long time ago. And well, radio amateurs are traditionally good in electronics, classical analog electronics. This is actually where we've come from. And the big problem is that we're in the middle of a revolution now, and actually we have to teach this community something different. We have to teach them to think not about the flow of electrons, but the flow of IQ samples in the end, and how to not to handle the change of the property of currents and voltages, but to change the flow of to modify the flow of data, which is similar but which is not the same thing. And I find it difficult. And actually, in all countries where we have exams, we don't just have exams, but we also need to teach people to pass the exams. And that's a very, very hard thing to do, because it's not about, well, spending one evening about digital signal processing. In fact, it's not enough, but you have to invest some more time. And the question is how to flatten this learning curve. And I think GNURadio is a good thing to go into it, and the documentation here and the tutorials also a very, very good way to go into that. And that's one of the reasons why I also think that we definitely need to translate all those tutorials in all different languages, and to facilitate the way into the topic in all countries of the world, and also to create some paths for radio amateurs in there. So that's very, very important. And I also recently read that, well, one of those abundant discussions whether amateur radio is dead, really. That's so funny. Because amateur radio is far from being dead, but it's being reinvented. We are reinventing amateur radio in the end. This is new amateur radio, what we're doing here. It's about creativity and letting creativity flow and inventing things and implementing your ideas and being free from having terribly expensive analytic electronics. You don't need a spectrum analyzer when you want to do a flow graph, right? You can just do that at home, and you don't even, in fact, you don't even need a something like a USRP or a HackRF, but you can start with your sound card, and this is really fantastic. I mean, you don't need to start with high frequency. You can start with low frequency. You can just sample from your sound card. You can whistle. You can try out a fast Fourier block with when you whistle into the microphone of your laptop. That works, and that's really, really cool. And that's a very first steps into it. And those things are really very insightful. And so this is why I'm also very grateful to what's been there. So very, very good. Okay, thanks for coming in. Thanks for sharing those things. Barry, Derek, Daniel, and Josh. Now, Michael has come in again. A few words from you, Michael. Your audio, we cannot hear you. We cannot hear you. I cannot hear you. Your audio is off. You're on mute. Something's not working.
Coming in 0 and 0.
Okay. Well, okay. I interpret that as kind of saying thank you also, right? Yeah, but I can see you.
Now it's working.
Now it works. Okay, very good.
Found the knob. I have been on the YouTube channel and all the time listening there. So I thank you very much for the last 1.5 hours. It was a great insight in GNU Radio, and I like that to get a little bit better information. And for me, it's impressive that you have a special date where you want to talk about measurement for ham radio. It will be very interesting for me personally. So thank you very much. I say thank you to all listeners who are here on our channel and listening to all these nice talks in the afternoon and especially in the evening, the last 1.5 hours. So have a nice evening, and later on there is a ham night in 1 hour or so. It's starting on the ham radio. So maybe we can see us later.
Yes, thank you very much. So let me at the very end, let me remind you that we needed to shift one talk to tomorrow, which is Adrian's talk. So we're going to start tomorrow at 12:30 local time, which is 10:30 UTC. And we're going to be back here in YouTube in the stream then again. And well, the ham radio world is also open, and that's an interesting kind of well, it's an adventure game, but you can go in there and meet people and talk to people and share a beer, a virtual beer, and so on, and have a lot of fun there. And we're going to run around there also now. Okay, then. Thank you very much. Have a nice evening, and see you again tomorrow. Bye-bye.
Thank you.
Bye.